Hey everyone, I want to just make a little video on Gaussian elimination or Gauss-Jordan elimination. Now with either of these, your end goal is to solve for your ordered triple without having to do any substitution. Okay? So now there's two ways to do it. You can either do it with equations or with matrices, but either way, you're going to kind of use the same tricks each time. And so one trick is just multiplying by a number. And the other trick is a linear combination, and that's the most used one. Okay, so I'm going to do this without matrices for this time, and I'm just going to kind of use equations. So for here, I'm going to name each equation. So the first one is going to be equation 1, and then equation 2, and then equation 3. Okay, now your goal, our first goal here is going to be to eliminate the x's. And so the easiest way to do that for me is to use this minus x to get rid of the other x values. Okay, so literally if I do equation 2 plus equation 1, I'm saying take that negative x, and then you have to do it to the entire equation, and add it to this equation 1. Okay, negative x plus x is 0. Negative 3 plus 1 is negative 2y. Negative 2 plus 1 is a negative 1. That equals 0. Okay, and I'm just going to name this equation 4. I'm going to do the same thing with equations 2 and 3, but this time, in order to get rid of the 2x, I would need a negative 2x. Okay, which means I really need 2 times equation 2 plus equation 3. Okay. Now for that, I'm going to do 2 times equation 2. So I'm going to get negative 2x, 2 times negative 3, 2 times negative 2, and 2 times positive 2. And I'm going to add that to equation 3. Okay. So when I add that, I get 2x, and a minus 2x is 0. Negative 6 and negative 2 is negative 8y. Negative 4z and 5z is a positive z. Negative 14 and 4 is a negative 10. And I'm going to name this equation 5. Okay, so now I have two equations with only y and z. So it basically simplifies down to a two-variable system. Okay, I'm going to rewrite that on the next page. So I had negative 2y minus z equals 0. And I had negative 8y plus z equals negative 10. Okay, so now from looking at this, I couldn't do either variable. However, the z variable would be easier. Okay, so if I just take equation 4 plus equation 5 and add them together, I would get negative 10y equals negative 10, because the z's would cancel. And now you can just do regular linear solving. So if I'm multiplying by a negative 10, in order to get to the other side, I would have to divide by a negative 10. So I would get y equals 1. And that's my first coordinate. Y equals 1. Once you have a coordinate, you can then plug it back into any equation you want. So for me, I'm going to go ahead and use equation 4 and say I would get negative 2 times 1 minus z equals 0. So I have negative 2 minus z equals 0. So negative 2 equals z if I add z to both sides. So now I have two coordinates, and then I can move on to my last one. So for my last one, I'm going to use equation 1 that said x plus y plus z equals negative 2. So I have x plus 1 minus 2 equals negative 2. X minus 1 equals negative 2. So x has to equal negative 1. Okay, now I'm not done. In order to be a solution to a system, you have to write it as an ordered triple because it represents that point of intersection. So for my final answer, I get negative 1 for x, 1 for y, and negative 2 for z. Okay. If you have any questions, please feel free to email and ask.